Hello, today we're going to continue our study of how to solve quadratic equations. So we know that we can solve them by graphing, and to find solutions we look for the roots, also known as x-intercepts, also known as solutions, also known as, forgetting something there, one of the synonyms. Well, it's good enough for now. But I know graphing is not always your favorite option. It's good to see approximately where it hits the x-axis, but I know it's kind of annoying to have to do that on a regular basis. We also have solving by factoring, which is great. However, not all equations are factorable. So I have one written here. It says x squared plus 6x minus 2 equals 0. I have the 0 for you, but if you try to factor this one does not factor. You can't get it to factor. So some things, it's a nice option, but it doesn't work for everything, so that's a pain. Now, the thing that I showed you yesterday with what has happened to the x and how do I reverse it, if you have a clear sequence of events that you can write down forwards and then reverse backwards, that works out really well. We like it. However, this is not in that format. But what I'm going to teach you today is a method called completing the square that will allow you to take an equation that's not in that clear format of this is what has happened to my x and force it to be there. Okay, so let me talk about what it is based on first. It's called completing the square, this process, and they named it that because they want you to actually think about making a square. So what makes a square and not just any old rectangle? Like what's special that makes it a square? Well, the length and the width have to match, right? You have to have the same distance on those sides in order for it to be a square. Otherwise, if they have different numbers on the sides, it's just a rectangle. So I am going to make a square out of this. So remember when we drew an area model to show these? Well, instead of just drawing any old rectangle, I'm going to make sure that this is a square. So I have to have the same length and the width here. Okay, so I'm going to put my x squared inside here. So now if you remember, when we were using this model, we had x's that showed up in two places. There were some x's up here, and there were some x's over here. Okay, so in this, I'm working with 6 x's. I have 6 x's here. So I have an x squared plus 6x. And if I want this to have the same length and width, then how many x's do I need to put in each of those zones? Well, if I split it up evenly, so I have the same length and width, I'm going to put 3 x's in each of those zones. So to get this x squared, I would have to have an x by x. X times x is x squared. To have a 3x in this top box, I would need an x plus 3, because if you think about multiplying the length times width here, 3 times x would give you that 3x. Same thing here, because x times 3 would give you this 3x. So we are making a square here, okay? So this is why they call it completing the square. So I want to finish out this square here. What would finish out this square? Well, if it's a 3 by 3 section, 3 times 3 would be 9. So I would need to add a 9. Let's see, I think I'm going to do that in green. So plus 9 would complete that square. This completes or finishes out the square. As a reminder, let's put here, squares always have equal sides, same length and width. Okay, so a 9 is what would complete this square here. I think I'm going to have you practice that part of the skill before I finish out solving this equation by completing the square. I just want you to get the idea of that process. So I have some more written here where we can complete the square. Let's see if you can see all of these. There we go. So 1, 2, 3, 4, 5, 6 problems here. I think I'll do one more with you to help you make sure you're seeing this. Okay. So I'm going to draw a square off to the side here. And draw my zones inside of it. So I have an x squared. So your x squared is always going to be in that first box. Well, how do you get an x squared from multiplying a length times a width? And it's got to match. Same thing here on the left as you put here on the bottom. Well, it's got to be x times x, right? X times x gives you x squared. Okay, so now in the problem I have 10 x's. So if I have 10 x's and the x's are going to go in these two zones here, and I need it to match. I need to have the same amount on the length as I have on the width. If I've got 10 x's to work with, split them up evenly. How many get to go in each of those zones? Well, that would be 5 x's. So 5 x's go in each of those zones. So that accounts for all 10 of the x's that I have. So that means that this binomial must be an x plus 5. And this one must also be an x plus 5. Check it out and make sure that it works. If you think about length times width for this zone here, 5 times x gives you the 5x. If you think about it for this zone over here, length times width, 5 times x gives you that other 5x. So here's where the process gets its name. What would complete this square? What would finish it out and make it a square? Well, length times width, 5 times 5, that would be 25. So I would add a 25 to complete that square. Okay, so go ahead and press pause, and I want you to finish drawing these out and figure them out. Now this last one, oops, can't see it, can you? This last one, ooh, I made tricky. I put a 2 in front of the x squared, and that's kind of bad news because a 2 isn't a perfect square. So what I want you to think about there is pull the 2 out front and work with the x squared plus 4x part to get your picture. Oh, can't see it, can you? There. I'm using the distributive property in reverse. Pull that out front and see if that helps you get a handle on what would complete the square. And then we'll worry about bringing it back up here to this blank. So there's your clue on that one. Also, I put 1 with a minus sign. So think about what this will do in your problem. Okay, so go ahead and press pause, get those worked out, and I'll see you in a minute. All right, I'm back. I've got some diagrams that were drawn out to help you with this. So for the x squared plus 2x plus something, I have this square drawn out here. Notice the length and the width match. So this box that will complete that square, it is 1 times 1, length times width, so that would be 1. So 1 is what would complete that square. Oops, I already had my plus sign, didn't I? Didn't need that. Okay, so on this next one, the tricky thing here was I put a minus sign in front of the 4x. So if I split those up, I'm going to have a minus 2x and a minus 2x. So here's what that does on your length and your width. I still have the x and x to get the x squared in this box. But then for my length times width, to end up with a minus 2x here, I need a minus 2 times that x. Same thing over here. I need a minus 2 times x. Notice my length and width still match. That's good. So now let's think about this last box. It is length times width. I'd be looking at a minus 2 times a minus 2. So if you multiply a negative times a negative, that will turn positive. So that's an important thing to note, that it came out to be a positive 4 that will complete or finish out that square. For the x squared plus 12x plus whatever, when you need to complete that square. So I have my x squared. I took my 12x's and split them evenly, 6x and 6x. So when I say split them evenly, it's like you're dividing by 2. Okay, you're splitting them into 2, half for the length and half for the width. And then to complete this square, this will be a 36. Now this next one had a trick to it because I had an odd number here. I had 5 x's. So if I'm going to split those, you're thinking half of 5, that'd be 2.5 in each. Now let me encourage you to keep these as improper fractions, 5 halves. Okay, it's true that it's 2.5. It's also true that it's 2.5. Those are both correct. But as you move into higher mathematics, you are going to want more and more to keep things improper. Darn mites. You're going to want to keep things improper more and more as you move up. Okay, it's going to be important that you are more used to working with them in improper form. So just leave it 5/2. So then when I go to multiply the length and the width here, 5/2 times 5/2 here, let me write it off to the side here. 5/2 times 5/2. If you multiply the numerators, that would be 25. Multiply the denominators, that would be 4. So 25/4 is what you'll have there, plus 25/4. Is it the same thing if you had, let's see, what would that be? 6.25 as a decimal or 6 1/4? Yes, those are all equal. But the improper form is going to be your friend here, okay? So just do that. Trust me on it. So now this complicated one, I had 2x squared. So what I've done for the diagram here is I split it into 2 squares. So here are my 2x squareds. I split them up, okay? Which means I have 4 x's to deal with in each one of those. So 2, 4, 6, 8. So you can still see all 8 of the x's represented here. So I wonder what would finish out one of these boxes. What would complete that square? So think length times width. 2 times 2, that would be 4. But I have a second diagram here. So 2 times 2 is 4. So if I look at just one of the pictures here, what would complete this is a 4, but actually to get the full picture, I would need 8 to complete the square of the original. You can see it this way. If you think about distributing this 2 back out, you see 2 times 4 is actually 8. So I'm actually adding 8 because I'm adding 4 to each of the 2 diagrams. So that's what would complete that square. So let's see what else I need to tell you about. Oh yeah, we got to go back and finish solving that equation. Okay, so when we started, we had x squared plus 6x minus 2 equals 0. So let me write that down here again. X squared plus 6x minus 2 equals 0. And we decided what would complete this square is having a plus 9. Well, look right here. Do I have a plus 9? No, I have a minus 2. I don't like that. That's not the number I want to have there. So I'm going to move that out of the way. So x squared plus 6x. So, okay, here's what I'm going to do. I would like a blank here so that I can fill in the blank. So I'm going to add 2 on both sides of this equation. Just to get that 2 out of my way, I don't like it. So plus, now leave yourself some space here. 0 plus 2 is 2 over here on the right side. So let's put some steps here. So the first step we're doing is we are, let's see. Well, I did this previously. We saw what would complete that square. See what will complete the square. And the minus 2 was not it. So move the constant out of the way. And of course, be fair on both sides. I'll put that. Be fair on both sides, because we always do that in solving equations. That's nothing new there. Okay, so I move the 2 out of the way. And so what will complete the square is the 9. So now this would change the equation, wouldn't it? If I just decide to add 9 on the left side, wouldn't that mess with it? Well, we got to be fair, right? So whatever we do on one side of the equation, we're going to do on the other side. So I'm going to add that on both sides. You can tell what's new. It's in green on both sides. So I'm going to put this step in green as well so you remember it goes together. So add what completes the square on both sides of the equation. So on the left, I could write this as x plus 3 quantity squared. If we look back up at the diagram, do you see this binomial is on the length and the width of that picture? Length times width, I could write it as x plus 3 quantity squared because it's the same thing twice for the length times the width part. So I'm factoring the left side. And let's also simplify that right side. 2 plus 9, we're talking 11, right? Simplify right. And now we can use our process from yesterday. So if I look at what is happening to my x, I have an x that's getting added to 3, and then it's getting squared. Those are the two events that are now evident in my problem. So here I am at the end of my equation. I want to get rid of the squaring. Well, how do you get rid of squaring? You square root. So I'm going to square root both sides. So I'm over here for the steps. I'm going to put solve equation. What happens to x? And reverse that. So I'm square rooting both sides. Don't forget you're going to need a plus minus sign there. On the left, the square rooting and the squaring cancel each other out, so you'll have the x plus 3, and then plus or minus the square root of 11. So we took care of the squaring. Now we need to take care of the plus 3 part. So how do you get rid of a plus 3? Well, you minus 3. So I'll go minus 3, minus 3. So x equals, and I'm putting the minus 3 out front of the plus or minus sign so we don't get mixed up with whether it's under the radical or not. And there's my square root of 11. So negative 3 plus the square root of 11 is one answer. Negative 3 minus the square root of 11 is the other answer. So two roots, two solutions to that. And we couldn't have found them by factoring because it wasn't factorable. And we could have graphed it, but it would have been a pain. And we wouldn't have been able to be that accurate. So there we go. I think that's everything I need to show you. So you're going to practice completing the square today. So remember that Jesus loves you and so do I, so do your math.